Hello, this is Mr. Win, and this video is about exponential functions. So exponential equations are a type of equation where the variable is now an exponent. The equations follow the form y equals a times b to the x power, where a is the starting point or y-intercept, and b is the growth or decay factor. It is growth if b is greater than 1. It is decay if b is less than 1. Now notice that b can never be equal to 1 or negative. Also know that x, the exponent, is only affecting b, not a. So a just stays a, but b has the exponent x affecting it. The graphs will be growing or decaying very quickly because b acts as a multiplier. For example, if b equals 3, then the graph will be constantly tripling. So here's a problem. Given the exponential equation, identify the a and b values and what they mean. Then create a table using x equals 0, 1, 2, 3, 4, and then graph it. So here we have y equals 1/4 times 2 to the x power. So again, this x is only for the 2, not for the 1/4. So we have a equals 1/4. This will be our starting point or y-intercept. We have b equals 2. This means we have growth since b is more than 1. If I make a table, I'll plug in 0 for x. I get just 1/4 of 0.25 because that's our starting point. If I plug in 1 for x, it doubles as b is 2. It's to 0.5 for y. If I plug in 2 for x, 0.5 doubles to 1. If I plug in 3 for x, 1 doubles to 2. Plug in 4 for x, y doubles to 4. Alright, so here's the graph. Notice there's 0, 0.25, 1, 0.5, 2, 1, 3, 2, 4, 4. If I had 5, it'd be 5, 8. So notice this graph is increasing very, very rapidly, or increasing exponentially. On the left side, it flattens out, but it'll never become negative. Here's another problem. Given the exponential equation, again identify a and b and what they do. Then create the table using x equals 0, 1, 2, 3, 4, and then graph it. So y equals 18 times 2/3 to the x power. So a is 18, that's our starting point, our y-intercept. And b is 2/3, this means we have decay. Now just be sure, if it's a fraction, that does not automatically mean decay. Sometimes the fraction is more than 1. For example, 3/2 is 1.5, meaning growth. But here, 2/3 is less than 1, that's about 0.6 repeating. So we do have decay. If I make a table, I plug in 0 for x, I get 18. Plug in 1 for x, I get 12, because that's 18 times 2/3. Plugging 2 for x, I get 8, that's really 12 times 2/3. 3, I get 5.33. 4, I get 3.56. So if I graph it, decay means graph will be going down. It's not growing anymore, so it starts high at 18, then goes down, and then down to more, down to more, down to more. It keeps going down, and then it flattens out very, very quickly. So that's a decay graph. Alright, population growth or decay problems are a very common example of exponential equations in real life. The formula when percentages are involved is y equals a times 1 plus or minus r to the t power. Now notice b is now 1 plus r for growth or 1 minus r for decay. Because when you have 1 plus number, that's bigger than 1, growth. When you have 1 minus number, that's less than 1, that's decay. Also, don't forget to change the percent into a decimal. So here we have a man counted 50 rabbits in the park. If the rabbit population grows 30% each year, what's the exponential equation that models this? So first, we know 50 starting rabbits means a equals 50. Then 30% means r equals 0.3. And growth means we use 1 plus r. If it was decay, we'd use 1 minus r. So 1 plus 0.3 means b equals 1.3. Lastly, plug it all into the formula for our final answer. Y equals 50 times 1.3 to the t power. Because t is basically time, it's like x, in years. So we want the initial population, t would be 0. If you don't know the population in 2 years, you plug in 2 for t. The population in 1 year, you plug in 1 for t. And that's it. Hope you enjoyed the video. Good luck on the quiz. If you have any questions, make sure you ask your teacher. Thanks for watching. Bye.